Dear students, today we are going to discuss the chapter optics, ray optics, in which the first topic comes light. What is light? Human light is sensitive to very small part of electromagnetic spectrum, that is visible light. Visible light of electromagnetic spectrum having wavelength from 400 nanometer to 750 nanometer. See, visible light. This is electromagnetic spectrum. Electromagnetic spectrum. From here, some nanometer starts from some electromagnetic spectrum must have read in the electromagnetic waves, and in which we will get visible infrared, so many ranges. Here, this say about 400 nanometer to 750 nanometer. This part of electromagnetic spectrum. The electromagnetic spectrum consists of wavelength from here to here. Electromagnetic consists of wavelength from here to here. But this out of this spectrum, this wavelength, that is visible light. Visible light. This part of electromagnetic spectrum is called visible light. This part is very sensitive to our eyes, through which we can see the object. Now next we can see the properties of light. What is properties of light? The property of it is, first, it is an electromagnetic wave. It is an electromagnetic wave. As I already told you, it is an electromagnetic wave, part of electromagnetic spectrum, forming the part of electromagnetic spectrum, having the wavelength range in the spectrum from 400 to nanometer to 750 nanometer, and it is transverse in nature. Same thing, this what is transverse in nature? Two is transverse. Verse, this lay is transverse. One is longitudinal wave, the motion. One is longitudinal motion, and another is transverse motion. In +1 waves, you must have studied what is transverse, what is longitudinal. Now let us not focus on it. This also we must have studied in electromagnetic. So otherwise also I will be uploading in electromagnetic chapter number 8 Cbse. And it is applicable to other boards. Only thing, then chapter number may be different. Okay, no problem. I will be loading this one. Transfer means the electric field and magnetic field both will be oscillating perpendicular to each other. That is, electric field is this is x-axis. Electric field is oscillating like this. Magnetic field will be oscillating, and the waves. What is the direction of movement? And this will oscillate like this. This will oscillate like this, and the direction of propagation, it means the direction of travel of the wave will be along the direction in which the magnetic wave and electric fields are oscillating. So this wave will be traveling. This will be perpendicular to the electric field, and magnetic field will be oscillating perpendicular to each other, and along the direction the wave will be traveling. So further in detail you can study from electromagnetic waves. First is, it is electromagnetic wave, needs no medium for propagation. It needs no medium for propagation. No medium for its propagation. What do you mean by propagation? Propagation means the direction of traveling. Transverse in nature, propagation. The light travels in a straight line in a homogeneous medium. What do you mean by homogeneous medium? Homogeneous medium means throughout the medium, the characteristics of that medium is same, no change. That is called homogeneous medium. So light travels in a straight line in a straight line in a homogeneous medium called rectilinear propagation. Rectilinear propagation. What is rectilinear propagation? Moving in a straight line. Light moves in a straight line. It cannot move with a bend. Light as it is. Okay. And light consists of photons of energy. Photons of energy means light consists of photons of energy in the form of photon. What do you mean by photon? Photon means energy, it consists in the form of packet and not as continuous. We will be studying in modern physics in detail about this photon. Okay, the path of the light, suppose here light's ray is coming like this. The path of the ray is called, path of the light is called ray, R-A-Y, ray. And the bundle of such light rays, bundle of means several light rays, we call it as beam. We call it as beam. We call it as a beam. And the velocity of the light is given by the formula. Velocity of the light, given by the formula, frequency into wavelength. Where this is frequency, this is wavelength, and this is velocity of light in any medium, because light will be traveling in several medium. Air medium, glass medium, water medium, paraffin, wax. So every medium, its quality changes, its velocity changes. Medium to medium, its velocity changes, but only one thing which is not changing at all, is its frequency. So the frequency of the light wave does not changes, because light is characterized by velocity, wavelength, lambda, frequency, and intensity. So these all, the light is characterized by these all the things. What is these all the things called characterized by these all the things? So velocity, wavelength, lambda, frequency, and intensity. What do you mean by intensity? Intensity. What is intensity? The light energy, see, when light is flowing, propagating and falls on some medium, say this is a medium, it falls on a medium. When it falls on a medium, light energy is incident. The energy is also moving along with the light in the form of photon. Energy moves along with the light energy. Light possesses energy in the form of photon. So this is the unit area. Light is incident on this. So intensity of the light, how we measure the intensity of the light? The intensity of the light is given by light energy possessed by the light, incident per second per unit normal area. What do you mean by that? Incident energy, incident per unit normal area. What do you mean by that? How much energy is incident striking a surface per unit second per unit area? That is called intensity of the light. I say intensity of the light is the light energy incident per second per unit normal area. Behavior of light at the interface of two media. What is interface? So this is a medium. So you can say this is glass, medium 2. This is air. So this is air. Medium 1 air. This is glass. Okay. there are two medium and light is incident on this one and this medium. This is interface. This is interface. What is interface? Interface, the surface separating both the media is called interface. So when it is light is striking incident ray, we call it as an incident ray. When incident ray is striking at a surface, at the interface of the surface, a part of the energy is reflected. That is incident ray. This is a reflected ray, and part of energy is transmitted into the second medium. Part of the energy is transmitted into the second medium. What do you mean by second medium? Second medium is glass. This is different medium. This is different medium. So therefore, these and these are not homogeneous. These and these are homogeneous. These and these are not homogeneous. Two different medium. So it is called transmitted or refracted ray. So when when the light is incident on the interface of a medium, between two medium, a part of energy is reflected back into the original medium, same medium itself. Part of the energy is refracted or transmitted to the second medium, and part of energy is absorbed by the interface itself. So that is called absorption energy. Now what happens when it is coming? Now when this is incident ray will have velocity, wavelength, intensity and frequency. When incident rays have got, so we call it as V, gamma and okay. Then reflected ray, RR, reflected ray. What is reflected ray? The velocity, what about the velocity of refracted ray? It will be same. Why it is same? Because it is passing to the same medium. Within the same medium, the velocity remains always constant. You must remember. So velocity will be laid in the, so because since it is in the first medium, this is also in the first medium. So velocity, this is V1 is equal to V. Or here V2. V2 means velocity in the second medium. Velocity in the second medium, transmitted medium or refracted medium are class P's. What happened? The velocity, since the medium is changed, the velocity will change. In fact, it is rarer medium means velocity is high, denser medium means velocity is low. And this is a denser medium, this we will see elaborately in refraction. Now here V2 is not equal to V, because here the velocity is same. V2 is not equal to velocity of the incident light, but V1 is equal to velocity of the incident light. Second thing, so we have talked about velocity. What about wavelength? Wavelength of incident light, incident ray, lambda 1 is equal to reflected ray, lambda 1 is equal to lambda 2. Lambda 1 is equal to lambda 2, because the wavelength of this light is reflected back in the same medium itself. So the wavelength of this light will be in the same medium. That's why the wavelength of the incident second medium, the wavelength of the second medium is equal to first medium, that is here, refracted ray is equal to wavelength of the incident ray. This is wavelength of incident ray, this is wavelength of the reflected ray. So therefore, the reflected ray will have the same wavelength as the incident wavelength. Okay, but lambda 2, that is wavelength of the ray refracted or transmitted, will not be same as wavelength of the reflected ray, wavelength of the incident ray. So this wavelength and this wavelength will not be same. So this is V1, lambda 1 is equal to lambda, and lambda 2 is not equal to lambda. And we have talked about this one. Then intensity. what happens to the intensity? First, intensity, the incident ray, we have gotten some intensity. Some portion of energy is gone because intensity is nothing but what is light energy incident per second, light energy incident per second per unit normal area. So some part of the energy is transferred here, reflected back, some part of the energy is absorbed and gone along with the refracted ray, some energy is absorbed by the interface itself. So intensity of the incident ray, this is incident ray's intensity. I1 is not equal to I2 is not equal to I, because some portion of energy is gone here, some portion of energy is gone, rest is absorbed. So all the intensities will not be same. So how you differentiate between the mirror and lens? If this portion, suppose if you have a piece, if you have this portion is painted and this is polished, so light will come and reflect. It cannot penetrate through. So light cannot be refracted. One side is polished and one side is coated. And one side is, if nothing here, this is not coated, this is polished. If this is not coated here, and this become transparent. Transparent means light can be reflected as well as it can be transmitted. Right? Reflection. What is a reflection? Reflection means what? A well polished surface, this is top is well polished, bottom side is coated. So this entire things form a mirror. So this light on incident, when incident on the surface will be reflected back, it will not be transmitted. So we will take a mirror now here. What is mirror? A mirror, one side is coated, other side is well polished. The polished side will transmit the incident light on it. So a light is incident on this like this. So this we can say I. So this is called incident ray. Incident ray. We will use in short IR. So now it is also the incident ray will always be reflected. Reflected means so angle, how we will measure the angle? Angle we will measure for incident ray as well as reflected ray with respect to the normal. Always remember, angle is always measured with respect to the normal. So okay, what is normal? How we can make the normal for any surface? For any surface, how we can calculate the normal? Normal is where the incident ray is striking. We call it point P. Where striking the surface, at this surface, normal to this means perpendicular to the surface. We have to draw perpendicular. Here also we can draw. Here also we can draw. But this is at the point of incident. We have to draw the incident. We have to draw the normal. So normal, always using a dotted line. Normal. So this is a normal. So with respect to normal and the incident ray, the angle between the incident normal and is called angle of incidence. So I is equal to angle of incidence. So this ray will be immediately reflected back by the same surface. So the rays, the path of the rays will be always thicker line. This will be a dotted line. Okay. So the reflected ray R, reflected ray. The reflected ray will be immediately reflected back with the same angle as I. incident angle, and so this is called reflected angle, reflecting angle. So reflecting angle, how it is measured? It is also measured always with respect to normal. Normal is always drawn perpendicular to the point at which the ray is incident on the polished surface on the mirror. So this is R. So we can say R is equal to angle of reflection. So we can say angle N PI is equal to I, angle NPI, angle NPR, angle NPR is equal to angle of reflection. This is angle of reflection. Okay, now we have got the loss of reflection. What is loss of reflection? That we will be discussing now. So, loss of reflection. Loss of reflection. What is reflection? A mirror. Mirror means what? A smooth surface. This is polished surface. This side is coated. When light is incident at this point, we say point P. Light is incident at point P. This is called incident ray, and it will be immediately reflected back in the same medium. So a reflected ray, that is R. Normal to this reflecting surface will be perpendicular, that is normal. So this is normal. So this is with respect to normal, the incident ray angle is the angle between normal and the incident ray is called angle of incidence. This is the normal, and reflected ray is called angle of incidence, angle of reflection. The normal, the angle of incidence as well as the angle of reflection are always measured from normal to incident ray, normal to reflected ray. So first law, what is of loss of reflection? Loss of reflection. First law, what the first law says? First law says the angle of incidence is equal to angle of reflection. That is angle N P I is equal to angle N P R. That is I is equal to R. This is very important result. This result we will be using everywhere. And normal. How to draw the normal source? You should be able to know. So normal is measured. So first law is angle of incidence is equal to angle of. Okay. The second law, what it says? The second law says angle of incidence, normal and reflected ray all lies in the same plane. Now we see here. This is, now we see this is the plane, and now we just, this is the reflecting surface. We see this is the reflecting surface. This is reflecting surface. This is the plane normal to the reflecting surface. Okay, in this plane, reflected ray, normal, and incident ray, normal, and plane all lie in the same plane. This is the second law. Second law, what it says? This plane, that is a plane here. We will draw it here. It is not visible clearly. This is incident ray, reflected ray, normal, all lie in the same plane. So now we got another plane. So it means this plane, the plane which is perpendicular, in this plane, this is a plane where reflecting surface comes like this, goes like this is normal. All are lying in this plane, which this plane is perpendicular to this reflecting mirror. So this is the second law. Second law says incident ray. Second law says incident ray, reflected ray, and normal all lie in the same plane. Now you see, if you look at this side, suppose this is the mirror like this, if you are seeing like this, like the rays are coming like this. Now when you see like this, you will find all are lying in the same. If you see through this way, this incident ray, reflected ray, normal, all are lying in the same plane, same straight line. You will see it like this. You will see it like this. This is normal portion. This is incident ray, this is reflected ray. Why reflected ray looks like this? Even if you see this, if this will be looking like a straight line like this. When you see this, this is incident ray, this is reflected ray, this is the surface. Okay. So this is all about the second law. Now, incident, how you will calculate the normal for spherical surface. That is also, you will have always some doubt. This chapter is not difficult chapter, it's a little bit confusion, so we will clear all the confusion now. See, for a plane mirror, what is plane mirror? This is the plane mirror. There is no problem in drawing normal. This is the point of incident. At the point of incident, draw a normal. This is normal. With respect to this, we have incident ray and we have a refracted ray. Incident ray and refracted ray. And from normal, if you incident ray is angle of incident, this is angle of refraction. Now, in case of spherical surface always, in case of a sphere, from the center, if you draw the radius is always perpendicular to this tangent. 9th class mathematics, you must have studied. If you draw a tangent at this point, and the radius from center to this tangent and the tangent both will be at 90 degree. It means anything that comes from the center is normal to the point. The line drawn joining center as well as the point and the circumference of the circle will be perpendicular to the tangent. So let us start going deep into this one. Now let us see a spherical mirror like this. This is a spherical mirror. This side is coated, this side is polished. So we said light is falling here like this. So what is the normal? At this point, how we will find out normal? At this point, how we will find out normal? Here also, if the normal will be different, here normal will be like this, here normal will be like this, because it is not a flat surface, it's a curved surface. So this spherical sphere is supposed to have its center. From the center, you draw the radius and extend this radius. This is the normal for this one. It means for the curved surface, if you draw from the point of incident to the center of the curved surface, if you draw the line, that becomes normal to the point. So now when a ray is falling like this, with respect to normal, so this will become normal. So this is angle of incident, and exactly same angle according to law of reflection, this is angle of refraction. So this is the normal. How to draw normal? From the center at the point of incident, draw a dotted line that becomes normal to the incident light at that point P. Suppose if you have, because now if you have point like this, now the center comes here. At this point some light is incident. So say incident like this. Incident, so this is I, incident ray, this is refracted ray, this is normal, angle of incident, angle of refraction. So you should not have any problem in calculating angle of incident. It is always with respect to normal and incident ray. Here what you say, from here, draw this becomes normal, exactly the same angle. This is I, this is R. This is Y, not this one. Sorry, this is the normal. So because this is a coated surface, no light will come. So if light is coming like this, this is a reflecting surface. This surface is reflecting. So light will be reflected like this. This will be I, this will be R, and I is equal to R as far as the reflection is considered. But refraction is considered, angle of incident will certainly not be equal to angle of refraction. But in case of reflection, angle of reflection is equal to angle of reflection. Now if a ray is passing normal to this, suppose if it is a ray is passing normal to this surface, a ray is passing normal, and at this surface, will be the normal also. This will be the normal. The ray is incident like this, and ray after that it will retrace its path, because angle I. What is the angle between normal and the incident ray? So I is equal to 0. So R will be has to be 0, because I is equal to R according to law of reflection. So when this is normal, therefore when a ray is incident along the normal, along the perpendicular to the surface of the reflecting surface, it will retrace its path. Types of reflection. Now we are going to talk about types of reflection. One is regular reflection. Another is diffused reflection. First we will see a regular diffraction. What is a regular diffraction? Regular diffraction means the reflection occurs at a smooth surface, smooth mirror. The surface is smooth, it means normal at every point, and the smooth surface is exactly parallel to each other. So let us see. First, smooth surface. The regular reflection takes place at smooth surface. This is the smooth surface. This is the smooth surface, and this is smooth surface, this portion. When a ray is falling like this, incident, parallel rays are falling on the smooth surface. These are the parallel rays. Assume that this is parallel. So exactly, I can't say it's, I can draw. So this, assume it's a parallel rays. Parallel in incident ray, all are incident ray. So it will have a normal. It will have a normal. This will also have a normal perpendicular to the surface. This will also have normal perpendicular to the surface. Since all the normals are parallel, this will be reflected back. This will be reflected back parallel. This will be also reflected. So it means all the normals are parallel. As it is, all the rays are incident rays are parallel. This is a reflected ray, this is a reflected ray, this is a reflected ray. Since it is a smooth surface, all the rays parallel, incident rays parallel, incident parallel on the reflecting surface will be reflected with the same angle of reflection. It means this all will be parallel rays after reflection from the smooth surface. This is your I, this is your R. Since surface is smooth, angle I is equal to angle R according to the laws of reflection. It means in smooth surface, when a parallel ray falls on it, all the parallel rays will be parallelly reflected. All the rays will parallel. All the normals will also be parallel. So you will get smooth surface, we will get well-defined image. We will get well-defined image from this kind of reflection. Now another one is diffused surface. Diffused surface means what? Diffused reflection. Diffused reflection. It occurs in only with it occurs only with This diffuse reflection occurs only on a rough surface. Rough surface means the surface is not smooth and it will be rough like this. So we can say this is rough. Like this. This is the surface. Surface. This is rough surface. In smooth surface, all rays after incident will move parallel and all the reflected rays will be parallel, all the incident rays will be parallel, all the normals also parallel because of smoothness, all the normals will be parallel, all the normals will be parallel. Whereas here, a ray out, let us think this is one ray, parallel ray is incident on this one. Parallel rays incident on this one. These are let us take two parallel rays. We may take, okay, let us take like this. One more ray, we will take one more ray. At this surface, for these all parallel rays. Parallel incident rays. These are the rays, parallel incident rays. For this, at the surface point of incidence, this will be normal. It will be reflected. I is equal to R. Reflected ray, incident ray. Now here, the normal will be like this because normal will be perpendicular to this place. So it will move like this. Reflected ray. Now, for this point, this will be normal. Accordingly, it will move like this. Okay, this is reflected ray. And for this will be normal and it will move like this. So it means all the incident rays are parallel, but normals at the rough surface are not parallel, hence the refracted rays also not parallel. This kind of reflection on rough surface is called diffused reflection. So parallel incident ray will not go parallel as a reflected ray. So all the rays are now reflected at certain point. Some rays will be concentrating at certain points, some concentration will be more. When you look from here, you will not get well-defined object because some places the rays are concentrated, reflected ray, some places the reflected rays are sparse, they are away. So the rays are reaching our eyes. The rays reaching your eyes, if it is more, we will get a well-defined image. If it is less number of rays are reaching our eyes, we will get a diminished image. So, in diffused reflection, the ray is not well-defined and it is concentrated at some point and it is intense some other point. Some place it is intense, some more intense than other place. In a regular diffusion, we will get everywhere, when you see everywhere the reflection ray, what is object, when you rays are reaching to our eyes, then only we are able to realize it. So when you see here, you will get a well-defined object. So this is all about regular and diffused reflection.